I wanted to give you another video where we're practicing different properties of exponents. So remember, whenever you have the same base, such as this -3, and they are multiplying these two quantities, the property is basically asking, like, how many -3s do you have total? So when they're the same base and you're multiplying, all we have to do is add those exponents. So we're going to get -3 to the 14th. Okay. If you try to type that into your calculator, it'd be a really big value, so that's why we're just going to leave it in exponent form. Okay, same thing. So I've got the same base and they're multiplying. So when it's the same base and they're multiplying, we just add those exponents up. So we should get x to the 14th. All right, same thing here. Now I've got a property about negative exponents that I could use. However, I'm going to still stick with the same concept. It's basically saying how many 8s do you have. So since they have the same base and we're multiplying, I'm just going to add those exponents up. So I'm going to take 5 plus -1, and that's going to give me 8 to the 4th. Looking at the next example, they don't necessarily give me a number here in the exponent, but I still understand that the property is when I've got the same base and I'm multiplying, all I have to do is add those exponents. So that's all that we can write on that particular problem. On example E, it's asking you how many -15s do you have. So here I have 5 -15s. Here I have 10 -15s, so in total, how many -15s do we have? Again, we can just add those exponents. So we're going to get -15 to the 15th power. All right, now something else that we can do when they are dividing. Okay, it's going to be kind of the opposite of what we did when we were multiplying. When we were multiplying numbers with the same bases, we added the exponents. You can think of division as basically subtracting the exponents. So when you write this, you can do this one of two ways. So this is one way. You can say, all right, well, I'm going to take y and I'm going to subtract the two exponents. And that gives me y to the 3rd. Now this is always over 1. Okay? Or you could just say y to the 3rd. Another thing that I like to do is I like to think of if there are 12 y's up top and there are 9 y's in the bottom. These 9 y's will cancel out with 9 from there, leaving us with 3 up top. And that's usually how I'll think of it. But again, you can just do the subtraction property. However, you might make a mistake on this next example. Some of you are going to want to tell me that the answer is c to the 7th, and I understand that error. You just need to be really careful. So when you are dividing values of the same base, you subtract the exponents. So it's 11 minus the -4. Okay, and subtracting a negative is equivalent to adding a positive, so it becomes c to the 15th. Another way that you could do that same problem is using your property of negative exponents. So I have a c to the 11th, that's going to stay put. Now anytime you have a negative exponent, if you want to clear it out, you need to flip its position on the fraction. So if this is right now in the denominator, I'm going to move it up to the numerator. Okay, and when I do that, it loses that negative exponent. And you can say that there's still a 1 down there if you want. And then how many c's do we have total in the numerator? Well, now we're going to use that same concept as above. We're going to add the exponents and we have the 15. So there's 2 different ways you could do that particular problem. All right, so same thing. I can subtract these exponents. So that's one option. I can say w, and I'm going to say -10 minus the -24. Okay, subtracting a negative is the same as just adding, so it's really -10 plus 24. So I get w to the 14th. The option that I personally like better is I like clearing out the negative exponents altogether. So if there is a negative exponent, it's going to flip the position on the fraction. So if this is right now in the numerator, to get rid of the negative exponent, I'm going to flip it to the denominator. So I'm going to move it down here. So it becomes w to the 10th. And this also has a negative exponent, so I'm going to flip it up there, and that's going to give me w to the 24th. And now I can think of it, if I had 24 w's up top and I had 10 w's in the bottom, these 10 are going to cancel out with 10 from there, leaving me with a w to the 14th. So again, I get the same answer, just using different properties. Okay, so on example I, you could give it a try. You could do the subtraction property, or you could flip your negatives. So I'm going to go ahead and just flip the negatives. No negative exponent here, so I'm going to leave that be. However, this one does have a negative exponent, so I'm going to flip its position to the numerator, and when I do that, I lose that negative exponent. Okay, and again, it's implied that there's a 1 down there. So now it's asking you how many m's do we have total? So we're going to say m 17 plus 23 is going to give me 40. So I get m to the 40th. All right, looking at the next example. So they have a power raised to a power. So whenever I have a power to a power, we're going to multiply the exponent. So I'm going to say x, and then we're going to take 5 times 11. So that gives us x to the 55th power. All right, now we're going to start getting into some examples where maybe they add a little bit more to it than we're used to. So another property that we talked about that said, like, if you've got information inside of a parenthesis, as long as it doesn't have addition or subtraction, all of it gets taken to that power. So I'm going to take the 2 to the 4th. I'm going to take the x to the 4th, also to the 4th, and then I'm going to take the y squared and take that to the 4th as well. All right, so 2 to the 4th means 2 times 2 times 2 times another 2. Okay, so we get 16. Power to power, we multiply those exponents, so that gives me x to the 16th. Power to a power, we multiply them again, I get y to the 8th. All right. So same thing, everything inside this parenthesis is going to be cubed. So making my fraction again, the 3 gets to be cubed. The y to the 9th gets to be cubed. And then don't forget about the denominator. The denominator also gets to be cubed. Oops, that was supposed to be an x. All right, let's simplify what we've got. 3 cubed means 3 times 3 times 3, which is 27. Power to power, we multiply. That gives me x to the 27th. And then in the denominator, we just have a y cubed. Looking at negative exponents again. Imagine that this is a fraction and that you have it over 1. Since it has a negative exponent, to clear out the negative exponents, I have to switch the position on the fraction. So the 8 to the 1st is going to move down to the bottom. What number is implied up here? A 1. So simplify that. That's just 1/8. Okay. Looking at this one again, I'm going to put this over 1 so we can see the position on the fraction. Right now, that power is in the numerator and it has a negative exponent. So I'm going to take this expression and I'm going to change its position on the fraction. So The 4 squared is now going to flip to the bottom. And again, what number is implied up top? A 1. And then let's simplify that just a little bit more. We have 1 over 4 squared. 4 squared is 16, so I get 1/16 for my answer. All right, let's look at the next example. I have -3 times my parenthesis, and one thing that I notice is that this parenthesis is raised to the 0, and we had a property that said anything to the 0 power is 1, and then I have a z to the 3rd. And then let's just go ahead and simplify some more. -3 times 1 is -3, and then we have the z to the 3rd. And final example, everything again inside here is going to be taken to that 3rd power. So I'm going to say 6 to the 3rd power. So 6 times 6 is 36, times another 6 is 216. Power to a power, I'm going to multiply them. So 2 times 3 gives me 6, so I get an x to the 6. Power to a power, I'm going to multiply them again, so that's going to give me y to the 15th. And then we're going to take this times this other expression, so I'm going to take -1 to the 3rd power. So -1 times -1 times -1 is -1. X to the 4th, and then cubed, power to power, multiply them. That gives me an x to the 12th. And then let's simplify again. 216 times -1 is -216. I have an x to the 6th and an x to the 12th. So total, I have 18 x's. And then I've got my y to the 15th.